Hello everyone, welcome to Bamane Pharm Lectures, where we make pharmacy simple. In today's lecture, we are going to look at part 2 of sodium chloride equivalent. We looked at part 1, and for those of you who have not yet watched part 1, I encourage you after this video, go and check out for that video so that you get the real foundation of sodium chloride equivalent as one of the methods used to adjust solutions to isotonicity. And to those of you who are new to this channel, my name is Bamane Pharm and I am a tutor. So let us pay keen attention as I take you through the steps involved in adjusting solution to isotonicity using sodium chloride equivalent. But before we can look at the steps, remember, we say that sodium chloride equivalent is the amount of sodium chloride in grams that has the same osmotic pressure as that of 1 gram of a drug. For example, 1% solution of boric acid has got a sodium chloride equivalent of 0.52. That means that 1 gram of boric acid has a sodium chloride equivalent of 0.52 grams of sodium chloride. So every time we say 1% solution of sodium of boric acid has a sodium chloride equivalent of 0.52, we simply mean that 1 gram of boric acid is osmotically equal to 0.52 grams of sodium chloride. So in our last part, we saw how we can adjust solutions to isotonicity using sodium chloride equivalent. But in that case, we were dealing with 1 ingredient. So we want also to look at the case where we have more than 1 ingredient in the formula. But to review, we shall have an example which is exactly about what we covered in our first part. But before we can look at this example, let us look at the steps involved when adjusting solutions containing more than 1 ingredient to isotonicity. So the first step, we calculate the amount in milligrams of sodium chloride required to render a solution isotonic with body fluids. Remember, when we talk about body fluids, we mean either blood plasma or lacrimose secretions or tears. So we know that 0.9% sodium chloride is isotonic with body fluids or blood plasma. So in our first part, they are telling us that we calculate the amount of sodium chloride required to render a solution isotonic with blood plasma. Since we are using sodium chloride as the adjusting substance at all times, the concentration of sodium chloride that is to be used is 0.9% weight in volume sodium chloride. So it means that a given solution, for example like this one, they are telling us to prepare certain meals of this solution. So that means we are going to obtain the amount of sodium chloride in certain meals in our first part. For example here, we shall say that 0.9 grams of sodium chloride, we know it is in 100 mils. That's if we say 0.9%. It means 0.9 grams of sodium chloride in 100 mils of water. How about the 30 mils? It means that our X will be equal to 0.9 divided by 100 times 30. So quantity we shall get here will be the amount of sodium chloride that is required to render this solution isotonic with blood plasma. The second part, we calculate the amount in milligrams of sodium chloride represented by each ingredient in the prescription, and we can obtain that by multiplying the amount of each ingredient by its sodium chloride equivalent. For example, like we say that boric acid, that 1% boric acid has got a sodium chloride equivalent of 0.52. So that means we have a sodium chloride equivalent of boric acid, but we need to obtain what amount of sodium chloride is equivalent to boric acid. We shall look at that as we look at our first example. Then in step 3, we shall subtract the value obtained in step 2. The amount of sodium chloride equivalent represented by each ingredient from the amount of sodium chloride required to render a solution isotonic, i.e. that is the value we obtained in step 1. Then, the first step, if we are to use an agent other than sodium chloride, let's say boric acid, dextrose, or potassium nitrate, is to be used to render a solution isotonic, we divide the answer we obtained in step 3 by the sodium chloride equivalent of the other substance, which in this case can be boric acid, dextrose, potassium nitrate, or any other. Let us look at the first example. Let us look at our first example. Calculate the quantity of sodium chloride required to compound the following prescription. The E value of cocaine has been given to us as 0.16, and the prescription has also been given to us. Cocaine hydrochloride is 0.2. Sodium chloride quantity sufficient because we don't know how much of sodium chloride is required to add just such a solution for isotonicity. Then purified water, add up to 30 mils, make the solution, make a isotonic solution, C, 1 drop in each eye. These are labeling instructions. So, solution will be, the first step, we say you obtain the amount of sodium chloride in 30 mils. The amount of sodium chloride in 30 mils. But remember that 0.9% sodium chloride is isotonic. And when we say 0.9%, we simply mean 0.9 grams of sodium chloride in 100 mils of the solution. So, if we know that 0.9 grams of 9 grams of sodium chloride is in 100 mils of the solution, how about the 30 mils? So, this will be 100 mils of solution contains 0.9 grams of sodium chloride. How about the 30 mils of the required? This will contain 0.9 divided by 100 times 30. And when you compute this, we shall get 0.27 grams of sodium chloride. So this is the amount of sodium chloride that is required to render this solution isotonic. with body fluids. So, step 2, we calculate the amount in milligrams of sodium chloride represented by each ingredient in the formula, of which in this case we have cocaine hydrochloride. So we shall also calculate the amount of cocaine, the amount of sodium chloride represented by cocaine hydrochloride, which we say it will simply be equal to the product of the mass of that ingredient, which in this case is 0.2, being multiplied by the sodium chloride equivalent of that compound. They have given us the sodium chloride equivalent of cocaine hydrochloride as 0.16. And when you multiply this, we shall get 0.032 grams of sodium chloride. So, this is the sodium chloride equivalent of cocaine hydrochloride, represented by cocaine hydrochloride. So, after obtaining the amount of sodium chloride equivalent represented by cocaine hydrochloride, step 3, we need to get the difference between the amount of sodium chloride represented by cocaine hydrochloride and that of sodium chloride that is required to render such a solution isotonic. And you can see this very well, that when we compare 0.032 grams and 0.27 grams, you realize that this value is far less compared to that is required to adjust such a solution to isotonicity. So, when we get the difference between these two, the remainder becomes the amount of sodium chloride that is required to adjust such a solution to isotonicity. So, we shall obtain the amount of sodium chloride to be added, which is simply the difference between the amount of sodium chloride required to adjust such a solution to isotonicity minus the amount of sodium chloride represented by cocaine hydrochloride. And when we subtract this, we shall get 0.24 grams of sodium chloride. So, after obtaining that, it means that our final product formula of the preparation will be cocaine hydrochloride, which is 0.2 grams. We shall have sodium chloride, which we have obtained as 0.24 grams, and then purified water add to 30 mils. That will be our final product formula. Let us look at the second example. And where you don't understand, please drop your concern in the comment section. I'll be right by to help you understand better. So, in our second example, generate a working formula for the prescription below. Ephedrine hydrochloride 1 gram, probutanol 0.5 grams, sodium chloride quantity sufficient, then distilled water add up to 200 mils. They have given us the sodium chloride equivalent of ephedrine hydrochloride at 0.3 and the sodium chloride equivalent of chlorbutanol at 0.24. But remember our first step, we calculate the amount of sodium chloride that is required to render such a solution isotonic. And in that view, you should at all times remember that the only concentration of sodium chloride that is isotonic with blood plasma is the 0.9% sodium chloride, which we say that it simply means 0.9 grams of sodium chloride in 100 mils of water. So we shall begin by obtaining the amount of sodium chloride in 200 mils of the solution. So we shall say amount of sodium chloride in 200 mils of the solution. This will be 0.9 divided by 100 times 200 mils. And when we compute this, we shall get 1.8 grams of sodium chloride. So this is the amount of sodium chloride which is required to adjust this solution to isotonicity. So our second step, we need to obtain the sodium chloride equivalent of each of the ingredients in the formula. In this case, we have been given two ingredients. That is ephedrine hydrochloride and chlorbutanol. So we are going to calculate the amount of sodium chloride equivalent represented by each of the ingredients. So we shall begin by getting amount of sodium chloride, equivalent represented by cocaine by ephedrine hydrochloride, which we say it is simply the product of the quantity given in the formula, which is 1 times its sodium chloride equivalent. And when we multiply this, we shall get 0.3 grams of sodium chloride as being the sodium chloride equivalent represented by ephedrine hydrochloride in this case. We shall also get the amount of sodium chloride equivalent represented by chlorbutanol, which will be the mass given in the formula being multiplied by the 0.24. And when we multiply this, we shall have 0.12 grams. So after knowing the amount of sodium chloride represented by the ingredients in the formula, we shall come and get the total amount of sodium chloride represented by ephedrine hydrochloride and chlorbutanol, and this will be 0.3 plus 0.12, and when we compute this, we shall get 0.42 grams of sodium chloride. So this is the total amount of sodium chloride represented by the ingredients in the formula. So we are going to go to step 3, which is step 3. We are now going to ascertain which amount of sodium chloride is required to render such a solution isotonic. Remember, the 0.42 grams is far less than the one that is required to adjust such a solution to isotonic. So in order to meet this demand, we get the difference between these two, and the remainder becomes the amount of sodium chloride to to be added in order to make an isotonic solution. And when you compute this, we shall get 1.38 grams of sodium chloride. So, this is the amount of sodium chloride that is required to adjust this solution to isotonicity. So, therefore, our final product formula in this case will be ephedrine hydrochloride, which is 1 gram, chlorbutanol, which is 0.5, then sodium chloride. This time round now it is not sufficient, it's quite sufficient because we have already obtained it, so it will be 1.38 grams, then distilled water, add up to 200 mils. And that is how we adjust the solution where we have questions or solutions involving more than one ingredient. Let us look at the third example. So in our third example, you're provided with the formula ephedrine hydrochloride 0.5, chlorbutanol 0.25, potassium chloride, quantity sufficient, distilled water, add up to 200 mils. This question is similar to the second example we have just looked at. So you can feel free to pause this video and calculate it out, and later you can check to see whether you can get the same answer with me. We shall begin by getting the amount of sodium chloride in 200 mils, which we know that this will be 0.9 divided by 100 times 200, and this gives us 1.8 grams of sodium chloride. And we said we use 0.9% sodium chloride because it is the only concentration, it is the concentration of sodium chloride that is isotonic with body fluids, let's say blood plasma or lacrimal secretions. So now we are going to get the amount of sodium chloride represented by each of the ingredients in the formula. The first one is ephedrine, which will be equal to the product of the mass given, which is 0.5 times its sodium chloride equivalent. And when we compute this, we shall have 0.15 grams. Then we shall also get that of chlorbutanol, which will be equal to the product of its mass, which is 0.25 times its sodium chloride equivalent, which is 0.24. And when you compute this, we shall approximately get 0.06 grams of as the amount of sodium chloride represented by chlorbutanol. So we shall come and get the total amount of sodium chloride represented by both ephedrine hydrochloride and chlorbutanol. This will be equal to the 0.15 plus the 0.06. And when you compute this, we shall get approximately 0.2 grams as our total amount of sodium chloride, represented by both ephedrine hydrochloride and probutanol. So after obtaining that amount, in this kind, we need now also to first obtain the amount of sodium chloride that is required to render such a solution isotonic. But when we compare the total amount of sodium chloride that is presented by the two ingredients in the formula with that is required to render such a solution isotonic, you realize that it is far less than this. Therefore, the remainder becomes the amount of sodium chloride that is required to adjust such a solution to isotonicity. So, amount of sodium chloride to be added will be equal to 1.8 minus 0.2. And when you compute this, we shall get 1.6 grams of sodium chloride. But remember, in this case, we have been given to use potassium chloride as the isotonicity modifier in this case. So we say in instances where other agents are required to adjust such solutions to isotonicity, what we do, we say amount of potassium chloride to be added will be equal to the ratio of the sodium chloride equivalent. Sodium chloride required, which in this case is 1.6, divided by the sodium chloride equivalent of that particular substance, which in this case it is potassium chloride 0.4. And when we compute this, we shall get approximately 4 grams of potassium chloride. So our final product formula is going to be, ephedrine hydrochloride. Final product formula is going to be ephedrine hydrochloride, it is 0.5, probutanol is 0.25, then potassium chloride is 4 grams. So by doing that, we shall have made that solution isotonic with blood plasma. Hope you have got it. Let us look at the fourth example. This is the fourth example, and it is your assignment. Get your calculator and a pen and solve out the amount of boric acid that should be used to make this solution isotonic with blood plasma. You can check out for the sodium chloride equivalent of the ingredients in the tables, the reference tables. And if you find this video useful, please like the channel, share the channel in your various class groups or with other students who may also find it very useful, and also subscribe to my channel to keep you more updated with more simplified pharmacy calculations, and also to make our channel grow bigger and bigger. Don't miss out in our next lecture. We shall also be covering freezing point depression as one of the third methods that is used to adjust solutions to isotonicity. Thank you for watching, and in case you have any question concerning sodium chloride equivalent, feel free to raise your concern in the comment section. I'll be right there to help you understand better where you're still not contented with it. Let us catch up in the next lecture. See you.